Good morning, my dear friends. See now, we'll begin with another this thing now problem. Okay. See now, a simply supported slab is 300 thick and is simply supported over a span of 8 meter. Okay. In sense now, a slab is there which has got 300 thickness and its span is now 8 meter. Okay. Its span is now 8 meter and it is simply supported. Okay. What he asks is now, okay, find the safe load that the slab can carry in addition to its own weight. Okay, in sense he has asked you to find out the live load, how much it can carry. The compressive and tensile stresses in concrete are limited to 12 newton per mm square and 1 newton per mm square respectively. In the sense, again he says permissible compressive stress in concrete is 12 and permissible tensile stress is 1 newton per mm square. Okay, it is pre-stressed with cables which are spaced at 200 mm center to center. See now, in sense here the cables have been placed in the slab which are at 200 mm center to center. 200 mm from here to here, from here to here again 200 mm center to center. Okay, each cable consists of 12 wires of 5 mm 5. Am I right? This cable consists of 12 wires of 5 mm 5, and the cables are situated at 50 mm from the soffit. Okay, so they are placed at 50 mm from the soffit. Okay, this in a sense, this is your CGC. I can call this as my CGC. Am I right? CGC lies at 50 mm from the bottom. Am I right now? And since it is a symmetrical section slab, I can call this as CGC. Am I right now? So CGC is here, CGS is here. This is the eccentricity. I think eccentricity can be now easily calculated. Okay, this is YT is 150, YB is 150. Am I right? YB minus 50 will give me eccentricity 100 mm. Am I right now? 100 mm is minus because it is below CGC. Okay, so now okay, 50 mm from the soffit. Okay, the pre-stress is 1000 newton per mm square. In the sense, in each cable he has applied a pre-stress of 1000 newton per mm square. Assume loss ratio as 85%. 85% loss he has asked you to assume. So now let us begin with, well, now as you know, since it is a slab, I will always consider it as 1 meter width of the slab. Okay, so area can be now easily calculated. Okay, area is 300 mm into 1000 mm, 300 mm depth, and in this direction I am going to now consider 1 meter. Okay, because always slab is considered as 1 meter width beam. Okay, so it is so much. But the moment of inertia can also be calculated. It is BD cube by 12. Okay, and WD can be calculated, dead load UDL. Okay, 0.3 meter into 1 meter in this direction. Am I right, sir? Now, so this will give me the area. Okay, area into density of concrete. Okay, it will give me so much. Okay, so once I know WD, I think I can easily calculate my MD. Okay, WD L square by 8 it is now. Okay, WD I know, L I know, span is 8 meter. Okay, it is so much. Now he says the cables are spaced at 200 mm center to center. As I said you, these cables have been placed at 200 mm center to center. 200 mm, 200 mm, 200 mm. Like that it goes. Okay. Therefore, in 1000 mm or 1 meter, how many cables are available? I think you can easily calculate them. Okay. 1000 into 1 divided by 200. It will give me 5 cables. Am I right? In the sense, in 1 meter width, I will get 5 cables because I have got 200 mm as the spacing. Okay, so now 5 cables are available now. Baba, area of each cable I think I can easily calculate. Okay, Baba, each wire is of diameter 5 mm. Okay, pi by 4 into 5 square, it will give me area of each cable, and such 12 cables are there now. Am I right now? So now it is so much. Now, but now total area of steel AS can be calculated as, but this is the area of one cable. Am I right now? So such 5 cables are there now. It is area of one cable into 5 will give me the total area of steel AS. Am I right? AS. Also, but now he has given FS also now. In the sense, he says that the pre-stress is 1000 Newton per mm square. In the sense, he has given the pre-stress in the cable in Newton per mm square. It is Fs as 1000 Newton per mm square. Okay. So now Fs into As, stress into area of the cable will give me the initial pre-stressing force F. Am I right? Initial pre-stressing force F is now stress into area. Stress is 1000, area of steel is 1178. So it will give me initial pre-stressing force as F as so much. But once I know the initial pre-stressing force, I think I can easily calculate the final pre-stressing force or the effective pre-stressing force, eta F. Okay, eta F is eta I know. Since loss is 15%, okay, eta is 0.85. 0.85 into initial pre-stressing force is so much. So it will give me so much as effective pre-stressing force or final pre-stressing force. Okay. So now, but since he has asked you to find out how much is the live load that you can apply on the slab, I have to consider the final condition or the working condition. Okay. Because in the working condition or in the final condition only your ML will act into play. ML will act. So now in working condition, I will write top fiber stress Ft as eta F by A plus or minus eta F EYT by I plus or minus MT YT by I. Either you can write it as now MD YT by I plus or minus ML YT by I. Or otherwise MD plus ML is equal to MT. You can write. Baba, I think all the values you know. I think you can fill up the values, all the values. So you will get the value of MT. MT as so much. Or MT can be written as MD plus ML. Okay. Therefore, from this, ML can be now easily calculated. ML is now MT minus MD. Okay. MT I know. MD I know. So I will get the value of ML. ML is so much. Baba, once ML is known to me, ML can be written as WL L square by 8. Okay. So now ML can be written as WL L square by 8. So now from this equation, ML I know, WL is unknown, span is 8. So the only unknown WL can be now easily calculated. Okay. So before this, I forgot to explain you one more thing. Top fiber stress Ft, it has to be equated to allowable compressive stress 12. In the problem he has given the allowable compressive stress as 12 Newton per mm square. Because in the working condition, when the slab is loaded by live load, it tries to now bend like this. It will try to now bend like this. Am I right now? Top fiber is under compression. Okay. So now top fiber stress has to be equated to its allowable compressive stress. When you equate this, the only unknown MT can be now easily calculated. So from this MT, you can easily calculate WL. Okay. This is first. Now similarly, now I will write the equation for bottom fiber stress now. Baba, bottom fiber stress can also be calculated as, or equation can be written as eta F by A plus or minus eta F EYB by I plus or minus MTYB by I. Am I right? And now bottom fiber, now it is under tension because the live load is now acting. The beam bends like this. Am I right now? The beam bends like this or the slab bends like this. So bottom fiber is under tension. So now its allowable tensile stress is 1 Newton per mm square. Am I right now? And since it is a tension, okay, I have to assign a negative sign to it. Okay. So everything I know here now except MT. So MT can be now easily calculated. Okay. So what this MT can be written as MD plus ML. Okay. Or ML can be written as MT minus MD. Okay. So MT is known. MD is also known. So the only unknown ML can be now easily found. But this ML can be written as WL L square by 8. Okay. So here now the only unknown WL can be now easily found. Okay. So now first equation and second equation will give you WL values. Okay, lesser of these two will give me the real live load. I can put it on the slab. So I think WL lesser one is, it is this itself now. Okay, 13145. This is the real live load I can apply on the slab. Okay, thank you very much.